Hello everyone, we're about to start the homework demonstration video for Module 6. I picked out two arguments that we're going to take a look at, and then one bonus one. So without any further ado, let's go ahead and get started. This is the homework problem number E7. This is from the third section here. We're going to take a look at this proof here and try to prove that it's valid. Now we've got two statements here as our premises. First one is a universal statement for any x. So like take any object in the universe, then we have this statement here. If x is a b, then for anything in the universe, it's an a, right? For any z, z is an a, and then not p. All right, so if this statement is true, then this statement is true. And that's for any x in the universe. And then we've got this other one here, is that there exists some x such that it is not the case that x is b. Now, unlike the other arguments that we've been looking at, these are not themselves statements that we can use for modus ponens, modus tollens, or whatever. These are statement functions. Right, so this is a way of generating further statements, right? We would have to actually instantiate this x. We'd have to actually pick something for the x to be in order to create new premises. So the first one, we need to go ahead and get some letter here for the x. One of the rules for instantiating these is that if you have an existential quantifier here, like there is some x, you can't instantiate this with a letter that's already being used. So we can't do like BA, for example, not BA, if A is already used somewhere else in the argument, further up in the premises. So we need to do this one first, but there is no restriction on universal quantifiers like this, for any x, So it doesn't matter if that letter's already been used. So we need to do the second one here, this existential quantifier. We need to use that one first. So we just pick A here. We did an existential instantiation on line 2 to get not BA. And so now we're going to do the same thing, a universal instantiation for 1, right? We'll use the same letter A since we can, and so then we have something a little more useful. It's a universal instantiation on 1. We just have the X here be an A. We picked A. And A could mean, we could use any letter. We can't use X, Y, and Z because X, Y, and Z are traditionally the ones that are used to represent anything, and in this case we can't use an anything here because we have an existential quantifier. This is just saying there is one, not anything. So there is one like this. We'll call it A. Alfred, perhaps, if you're a fan of Batman. So then we've got BA, if BA, then ZAZ, and then this whole statement, if this, then not P. All right, now at this point, we need to do a little bit of strategy because it's not entirely obvious how you can combine these up in any way. But take a look at premise number 4 here, the one that we generated from universal instantiation. It's a if-then statement, right? So if we were somehow able to get, say, P, we would be able to show that not this is true. But we're actually trying to get not P. So if we were trying to find not P, and not P is here, we need to somehow generate this statement right here. If we could somehow get, if BA, then if for any Z, AZ. If we could somehow get this, then we would be able to do modus ponens on this one, and 4 to get not P, which is our conclusion. This would be ideal if we could somehow manage to do this. All right, well, could we get this statement? Well, we've got this not BA here. So maybe if there's something that we could do involving not BA, and you look at this, you notice, well, there's one of those replacement rules that we had worked on a few weeks ago, and those replacement rules allow you to convert back and forth a conditional statement like this to a disjunction, an or. And if we were able to get this statement, not BA or ZAZ, we could use material implication to create a conditional from that, this conditional, BA then ZAZ. So if we were able to get this, we would be in good shape. And you notice we already have this part, which means we could just add this second part. It could come from, like last time, the power of the imagination. Right? We just invent it, right? So that's what we do. We have not BA or, since we can add anything with an or, not BA or ZAZ. And so now we can use material implication to get this, which is what we wanted in the first place, which then allows us to do modus ponens on 4 and 6 in order to get our conclusion, not P. Not bad. We win. Zebra steaks. Here we go. So that's the first one. This one involves a little bit of strategy. Right? I picked the next one at random as well. This one is from F4. This one is a little more straightforward. We've got first premise is for any x is both an f and x is a g. And then it's not true either. It's either not true that for any x is g or HA. And our conclusion here is that there exists some x, something that is an h. Right, that's what we're trying to reach. Well, first thing I want to do here is just do a universal instantiation on 1. Let's just pick a letter. Let's go ahead and keep the universal aspect to this, so we'll pick y. So we'll say, okay, y, which could be anything, y, it could be just anything at all, is both an f and y is also g. Right, so there's our universal instantiation on 1. And so then from there, we can simplify this part of premise 3, gy. So now we have gy by itself. Now take a look at 2 and 4. See this? It's kind of interesting. We could universally generalize gy, right, because we kept this y. Now if we had translated 3 with one of the letters like C or D, we couldn't then use universal generalization to create xgx. So the best that we could do would be there exists some x such that gx. We couldn't make it universal. So that's why we had to use x, y, or z in order when we instantiated number 1, so that then we can go back and generalize it here in 5. So using existential or universal generalization on number 4, we get x, or for any x, gx. Now take a look at number 5 and 2. Right? For any x, gx, and here we have an or statement. Either it is not the case that x, gx, or HA. And we know here that this side is false, because it's not true that not x, gx. In fact, for any x, gx is true. So this means that we can use disjunctive syllogism on 2 and 5 to get HA, DS 2 and 5. Right? All right, now we're extremely close to the conclusion. We can smell the zebra if you're the logic lion. And so all we have to do here is do an existential generalization on 6. And you can do existential generalization on anything. So we just say there is some x. If A is h, then it's true that there is some x that is h. In fact, that x happens to be A. We know that from here. But this statement then, if A is h, then there's at least something that's h. So we can do an existential generalization there on 6, and you notice we've created a premise that is identical in every way to the conclusion. And so we get the zebra steak. Logic lion gets to eat tonight. That's how you do the homework for this section. Now, one thing that you'll notice in the homework instructions, they'll say, don't use conditional proof, don't use reductio proofs for these. There's a few extra rules that you have to get into if you ever want to use generalization and instantiation inside assumptions. It's not that difficult, but they just cover that further in the chapter, and we're not going through that. But if you're curious about it, like how does this work? Feel free to read forward in the chapter a little bit to see how you would use these tools within a conditional proof or a reductio proof. The last one here is just a bonus. This is one of the ones, the English language ones, that you need to translate and then prove. And the original is, God is a perfect being, nothing perfect is unreal, so therefore God is real. I thought this was kind of fun. I couldn't pass it up. So what they suggested was to translate it as use G for God, and then use P for is perfect, and R for being real. So then I translate it like this, right? God is perfect, right? So that's just by itself. And then for any x, for anything in the universe, if that thing is perfect, then it's also real, right? So nothing perfect is unreal. I kind of did it as like a double negative. All right, there's no such thing as a perfect thing that is also unreal. Like for any perfect thing, it's going to be real. So then I did like this, and then our conclusion is, therefore, a real thing, right? God is a real thing. God is real. So for this proof, this is very straightforward. We simply do a universal instantiation on 2, right? So for any x, if x is perfect, then x is real, becomes if God is perfect, then God is real. All right, that's a universal instantiation on 2. And then you notice our premise number 1 is God is a perfect being, so we're able to use modus ponens on 1 and 3 in order to get, well, then God must be real. This is fun. This is a very quick and dirty version of an old argument called the ontological argument. And it aims to show that there is a God, that God must exist purely on account of the fact that the idea of God is that God is a perfect being. So the idea here is something like, to talk about God existing would be like talking about triangles having 3 sides. If something is a triangle, then it has 3 sides. Like if someone came up to you and said, "Oh, I saw a triangle. It was amazing. It had 5 sides." You're like, "Well, no, right? If you're counting the sides in a triangle, 3 must thou count, not 2, not 4, not 5, 3. So you must have seen a shape. I don't know what it was that you saw, but it was not a triangle. If it was, it would be 3 sides." And for you to say, well, this triangle had 5 sides means you don't really understand what a triangle is. You're confused. Well, the same way in this case, right? If you said, oh, there's a God, but God doesn't, or I'm thinking about God, but God doesn't exist. That's like saying I'm thinking of a triangle with 5 sides, right? Like, okay, you're thinking of some being. Okay, sure. Like maybe you're thinking of Thor or one of the Egyptian gods, Horus or something. Like, well, it's possible for those gods not to exist, but those gods aren't perfect. And in the case of the idea of God that we're thinking of here, God would be perfect, and nothing perfect is unreal. Now you might look at that second premise, right? For any x, if x is perfect, then x is real. And think, well, is that really true? I mean, surely there are some exceptions to this. And one of the illustrations I like to give my students goes something like this. Imagine I gave you the choice between 2 different things. No strings attached, either side, you pick. On one hand would be a brand new car, any car you want, you pick. And the taxes are covered, and all the maintenance and insurance is covered for the first 10 years that you own the car. You can pick any car, right? You want a Toyota Camry, you want a new pickup truck, you want a Lamborghini or a Bentley or something, no problem. You pick the car, I'll buy it, pay all the taxes, pay all the insurance, pay all the maintenance on it for the next 10 years. Okay, you can have that, or you can have an imaginary car that I also pay all the taxes on and the maintenance, which there wouldn't be any since it's imaginary. And all the insurance, which of course also I would cover. Obviously you would pick the real car. Right? The same thing. I said, okay, you're going to have two options here. No strings attached. One of them is vacation to anywhere you want for 10 days. And I'll cover travel back and forth. I'll cover all your meals, anything that you want to eat or drink. I got it. And I'll even make sure that I pay your work, your job, so that they don't lose any income from you taking this long vacation. You get to go whenever you want. You pick the time. Pick the time, pick the place, anywhere in the world. You want to go to Interlaken and ski? Great. You want to go to Cancun and party on the beach? No problem. Like whatever it is you want. You want to go to New York City and watch Broadway plays? You got it. 10 days, wherever you want to go. I'll pay for everything. I'll make sure nothing goes bad. Or you can have an imaginary vacation where you can do whatever you want and I'll pay for that, right? It's like, right? Everyone's going to pick the real one because the real one's always greater, right? No matter what it is, the real version is greater than the unreal version. If it's a good thing, like a vacation or a car or a house or something, The real one is greater in a good way. If it's something bad or evil, right? Like the difference between like a nightmare and some actually traumatic experience, the real one is always greater. It's greater evil for sure, but it's greater. So being real means being greater. Well, in that case, if something is perfect, and you said, well, it's perfect but also unreal, right? Well, it couldn't be perfect then, because the real version of it would be more perfect than the unreal version. So in that case, so this argument would go, we'd have to accept premise number 2, right? Unless we thought that it was possible for something to be not real and yet greater than the same, an imaginary thing being more real than the real thing. And like Coca-Cola says, you can't beat the real thing. Anyway, this is just a bonus. Remember to use the homework forum if you can, if you run into any problems or you get stuck. And good luck with the homework for this week. Oh, and I almost forgot. The zebra. All right. Good luck to everyone. See you soon.